I'm still like keen about this. I don't know why. And I told him you and I was not trying to see her because I was like not trying to meet people.
You had a good read week.
I feel like when it rains, it
Relax, you went to task.
was it relaxed?
No, exactly. So how was it?
Sunday early morning, but it was really hot.
Modern or is it like?
We were sleeping on my friend's left
It must be like
couch. It was basically a plus. Very sexy. Very
Nice wild flowers that someone knows like
Your friend is there or he
it's that's awesome. It's one and then and I did leg day, so I was like
Even if it's yours or if it's not yours. Yeah, yours. I'm sure.
The day we got to Paris.
Wow. Yeah, very cute. Reminded me like small
It's actually just like such a fun city. The jazz.
My brother's got it's nice with these other people. You yeah.
And then I went straight. We're gonna go to Barcelona.
Oh, you know, got the story. Pressure right away.
I trust you.
Saying to be something, but yeah, that's but it was very good. You had election yesterday or?
Like other people.
Went through stuff. Yeah,
We had interviews, and then we had our last interview the day after we saw you. But then like we went to the our Sunday roast. But then
so I don't mind the fact, but even for me, like every Monday stuff, there's a mountain to ask about. Every week,
I think turn around, like, don't turn back around, like, stay.
exactly, what is it going to be called? Yeah, like it was all like, very organized.
Still happy. I felt bad because I literally had to smack him because he literally kept hard. I like apologized after and he's like, no. He was like, I was literally.
It's always nice to see you guys, especially
I know because he was younger. Oh my god, no, he was cracking me up. He was like, young guy, does he like wear? No, and it's like, no. It's okay. He's like, my mom's so hard. Like, shut up. You sound like such a pure.
I like the math. The math presentation was, and he was like, ah, I know. Alright.
The first time we met my friend, he was like, oh yeah, I think you're going to pediatric neurology or pediatric gynecology. And that's like this audio. But I
more energetic than you were 2 weeks ago. Okay, so we are starting a new part of the course where we are talking more directly about policy design. So before the reading week, the assignment, we talked about the McKinsey. Remember that? We looked at that, and one of the important things that we discovered when we looked at that is that there are lots of different things we need to do to reduce emissions. And it follows from that we need policy instruments that are good at decentralizing the incentive to reduce emissions, right? Because if there are so many different ways to reduce emissions, it's going to be hard to design this in a centrally planned top-down way. And that leads directly, really, to the reason why economists turn to carbon pricing first as their preferred method of incentivizing reductions in greenhouse gas emissions. And that's what this week is about. It's about carbon pricing and carbon markets. Okay. So I asked you to watch 3 videos coming in here today. So, and all of these really doing the job of a kind of textbook in going through the issues. So mini lecture 7.1 was the standard theory of why an economic instrument would deliver emissions reductions at the least cost based on satisfying the equity marginal principle. And we finished that mini lecture by saying that, well, you could do this either with a tax or with an emissions trading system, and they would have the same results in terms of efficiency or cost effectiveness, right? And then in mini lecture 7.2, we said, well, hold on. Taxes and cap and trade are only identical under a very strong set of assumptions, so let's start relaxing those. So the first one we relaxed is the idea that we're operating in a world of perfect certainty, so we introduced uncertainty. We talked about how taxes and cap and trade operate under those circumstances. It was all about the slopes of the marginal benefits and cost functions, right? And that kind of ended with the punchline that, well, that analysis probably leads us to taxing. You can think of a world in which the slopes of the marginal benefit and cost functions are such that you would prefer a quantity instrument, but that really seems to be an argument that's more likely to hold in the long run. And the long run is not very relevant here because the whole theory of prices versus quantities kind of depends on making mistakes that you can't correct, right? So we can adjust for misestimation of costs and benefits in the long run. So we end up with this idea that, well, if it's just about efficiency under uncertainty, then we want to tax. But we also said that it's not exactly a dichotomy. You can make emissions trading systems look more like taxes. You can create hybrid instruments by introducing either price floors or price ceilings. Okay, so that was an important point at the end of that video. And then in mini lecture 7.3, we sort of broadened the comparison point to think not just about efficiency, but also about distributional issues. And that, led us to think about some dynamic efficiency issues around incentive problems, but also a lot about pure distributional issues, which have got nothing to do with efficiency. And this helped a lot in explaining why emissions trading systems are popular, right? Even if they're not textbook efficient under uncertainty. But basically they distribute the cost of reducing emissions they can do in a different way, particularly with free allocation, and then that's why we see a lot of emissions trading systems. Okay, so that is hopefully what I just said you all know already because you watched the videos. Okay. So what we're going to do today are, firstly, we're going to go through the 2 assignments. So I gave you a couple of problem sets to do. I hope you've tried those. For those of you on environmental economics and climate change, it should have been straightforward. They're a bit like what you've done for GY426, but even a bit simpler. For those of you who are not on environmental economics and climate change, you may have found them hard. That's okay. I think that it's interesting to try a problem set if you've never tried one before. And I also think that I hope that the problem sets will help show a lot of the fundamental principles here. And lastly, to reassure you again, you will not have to solve problem sets in the exam. So just relax and enjoy them, yeah? And then later this afternoon, I'm going to do mini lectures 4, which is much less kind of about the textbook of tax versus cap and trade and much more about the practice of how you actually design and implement these schemes in reality. So it's really particularly aimed for those of you who are or might go into policy jobs, might be responsible for actually designing a carbon pricing scheme or administering one. You might operate in a regulated business which is subject to one. You might end up working for a consulting firm which does work in this area. This is very much intended to speak to some of the more practical issues that you would encounter. So, that's what we're doing. So let's pull up the first of the 2 problem sets and just go through it all together to make sure that we're all on the same page about how to do it and the correct answers. Okay, so assignment 7.1. So we're in a stylized economy. We've got 4 firms. These firms produce stuff, imaginatively named. The firms differ in terms of their productivity levels. So they all have a profit function ax minus x squared. They have different productivity factors, and the different cases that we think about in this problem set are designed to make you think about the overall effects of different policy instruments and also their different incidents across these firms. Okay? Oh, and I should also, just to say, so this is one of these sort of textbook style examples where the only way that the firm can reduce emissions is to reduce it. So it's simplified in that way. There's no explicit modelling of abatement which would enable you to produce the same amount of output while reducing your emissions by paying some abatement costs. But implicitly, the abatement cost here is not producing. Okay? Many of you will have seen these kinds of textbook examples. Okay, so let us go through the different cases. So case 1 was just as a benchmark. So this is the unregulated system where the 4 firms can produce just whatever they like. Okay. So I'm sure that all of you have the correct answers already filled out in this table, right? So let's just go through it. So in the absence of any regulation, how much does firm A produce?
5.
Thank you. We're off to a good start. So now somebody else can shout out for the next firm with productivity of 20? 10. Next. And next. Well done. And then let's total profits.
25.
Good. Good. 225. Excellent, let's all go home. Right, so, very good. Let's just quickly check you all understand how to do this. So, we've got a profit function here, ax minus x squared. Let's call this profit pi as a function of output x. We just often use pi to indicate profits in economics because we're fancy and we like to show that we can speak Greek. Okay, pi as a function of x is ax minus x squared. So if you plot that, and probably those of you who are not can't remember calculus will have done that. You'll have noticed that this gives you a parabola, right? Of profits, pi as a function of output x, and we want to find where those profits are highest, right? The maximum of this function, it's going to be up here. At that point, the slope is 0, right? It's flat, okay? So we want to find the point where the slope is 0. We do that by differentiating this function and setting it to 0, okay? Which gives us, let me get a better pen. Try this one. So we have pi x equals a minus 2x. Set that equal to 0. 2x equals a, x equals a over 2, right? So that would be where this profit is at its, this profit function is at its highest, okay? And you can see that therefore, you can see obviously that if A is 10 then, optimal emissions are 5, 20 is 10, 30 is 15, 40 is 20, right? That's what you were doing here, whether you actually wrote out the derivative or whether you just plotted it in Excel and located the point where the profits were at their maximum, or whether you just stuck it into ChatGPT and told it to solve the problem. Hopefully, if you did that, you at least asked it to explain what it was doing. Normally, it does that whether you wanted to explain or not. So these are all the different ways that I imagine you solved this. Okay. So we would say, so this is optimal output. We often give that a star to indicate that it's the optimum. And then how do we use that information to find total profits?
Plug it back into.
Exactly. So we take the value that we get out of this, we plug it back in here, and that gives us total profits that we'll get. So say this is 5 for a term with output 10, it would be 10 times 5 minus 5 squared, which gives you 20. And you would do that for each of the firms. And hey presto, got that far. Any questions? All on the same page? So for each of the firms, they've got different productivity factors. They will have different profit function, different parabolas. For each of them individually, we're trying to find the point at which it's at its maximum. If we're doing calculus, we do it by differentiation and setting the derivative to 0. Otherwise, we just work it out in numbers. Then we take the results of that and we put it back into the profit function to tell us how much profit it's making when x is set to its optimal value. And that gives us the second one. And so this gives us the benchmark in the case where we've got no regulation. And it will be helpful for me to just keep a note of the economy-wide emissions and the economy-wide profits. So these are just the row sums here. So what's the row sum of emissions here? Somebody just toss up the row. 50, that's right. What about profits?
750, I think.
750. Okay. So that's our benchmark. So what we want to be doing here is we want to be, maths is already making me warm. what we want to be doing here is reducing emissions, and we're going to be interested in how much that's going to cost in terms of reduced profits. Okay, good. So, next example. And so if you did plot it, by the way, it would have looked a bit like this for the 4 firms. Right? Okay, so now we're going to start with now we're going to move into our first climate policy here, called command and control. You could think about it as a non-transferable emissions quota, where each of the firm is told that they can emit a maximum of 10 units. So in this case, what is optimal output for the firm with A equals 10?
5.
Next one?
10.
Next one? 10? Last one?
10.
Good. And profits? 5, 100, 200, because it's got it's higher productivity factor, 300. Okay. There's no math here really that's worth talking about. And we certainly don't want to get into inequality constraints and Kuhn-Tucker conditions, so we'll just draw it, right? We're basically imposing a constraint that says that the firms can emit a maximum of 10. In this model, production and emissions are 1 for 1. So we're basically saying you can only produce a maximum of 10. This constraint is not binding for the 2 firms that are unproductive. Right? Firm A only wants to produce 5. So it's been given a non-transferable quota of 10 and sort of shrugged. Fine. Firm 2 is the same because they would have wanted to produce no more than 10 anyway. But this is a headache for the 2 firms that happen to actually be productive as well, right? Because they would have wanted to produce more and now they can't. They hit the constraint. And you can hopefully already see that this is going to be an expensive way to reduce emissions, because we're clobbering the 2 productive firms, and we're not changing the incentives of the 2 unproductive firms. So already at the early stage, we can see what's probably going to happen here. But let's look at economy-wide emissions and profits. So emissions are what? 35. Profits are 625. Okay, so the policy is environmentally effective. We've reduced emissions by 50, and it's cost us 125. That's about all we can say now. We don't know if the benefits exceed the costs because we're not doing a cost-benefit comparison. We're not pricing emissions. We can't think about that. And we don't know yet whether we could achieve this reduction or a larger reduction at less cost. For that, we'll also think about some alternative policy instruments, right? But certainly, if we wanted to reduce emissions, we could do it this way. Relatively straightforward to administer. We know how many firms are in the economy and we have a sense of how much we want to emit. We'll just give them an equal share of that and tell them that they cannot go over, otherwise the managers get kneecapped or whatever. Okay, good. So now we're going to compare it with a tax. Okay. So now we're saying that firms can produce whatever they want, but they have to pay a tax on every unit that they produce, on every unit they emit, which is equivalent to every unit they produce. The tax rate is T, and suppose we set it equal to 10. So there are 3 rows here. The first one is output, which we'll go through in just a second. The second one is what I called gross profits, by which I meant profits before tax. And the third one is profits after tax. Okay, so let's do output. So for the first firm, get us off to a nice start there. 0, 5. Yeah. That's it. Now, did anyone understand what I meant by gross profits? Profits before tax, so it's straightforward for firm 1. We can just move on. What about firm 2? Yep, 75. Firm 3. Sure. That's it. And the last one. 375. If you're doing this on the spot, I'm impressed. Okay, profits after tax, 0. 25 I have. 100. 225. Good. Okay, so let's just explain that in a minute, but let's just tot up our usual economy-wide quantities here. Economy-wide emissions, that's the row sum there, that's 30, right? Economy-wide gross profits, I will just tell you that's 650. And economy-wide net, i.e. after tax profits, is 350. Okay, so first of all, solving this problem, principles are very similar. It just throws out, I'm just going to rewrite that because the pen is very weak. So before we had pi of x is ax minus x squared. Now we have this additional term, don't we? Minus tx. We still want to find, we're still doing the same thing, we still want to find the maximum of the function, it's just that with the new tx term added, it's going to change the position of the function. Okay, so when we differentiate this now, we have a minus 2x minus t equals 0, right? Which means 2x equals a minus t, and x equals a minus t over 2, yeah? And then we're just plugging in a, which we know, t, which we know. So for example, for the first firm, a is 10 and t is 10, so firm 1 is put out of business. Can't make a profit on any of it, so it closes. And then if we want to find profits, we plug this back into the profit function. To do the before tax profits, you just ignore this thing. Just use the original profit function. If we want to do after tax profits, we'll just put it back in. So that's how the tax modifies the problem. So it creates, in effect, a new cost of production. All the firms produce less than they would in the unregulated economy, yes. Okay. In terms of emissions, we have reduced them even more for a tax rate of 10. Emissions are going down to 30, sorry. Gross profits, however, are higher than they were in the command and control example. So here's the material of mini lecture 7.1, just given to you in a different way. I've showed you through these worked examples how I could design a price instrument which delivers an even bigger emissions reduction for a cost that is even lower than the command and control example. And the way that that has been done is by redistributing the emissions effort from the high productivity firms to the low productivity firms. In the command and control example, I explained to you how with the non-transferable quota, it was affecting the high productivity firms, but not the low productivity firms. The tax is working differently, right? It's causing reductions across the board. It's putting low productivity firms out of business altogether, but the high productivity firms are producing more. So this is really the essence of efficiency or cost effectiveness. Okay? It's working here. Now, the other important point I want to make is about the difference between gross profits and net profits. Okay? So what I have just said to you, I was talking about the gross profits, the 650, and you're probably thinking to yourself, oh, why is he talking about the gross profits? Surely he should be talking about the net profits. Well, the thing is, the difference between the gross profits and the net profits is the tax payment, right? The 300 that goes to the government. But in public economics, we don't normally think of that as a cost, right? That is just money moving from one agent in the economy to the other. We call it a transfer. Because the 300 that the government receives, it can use to do things like fund public spending, or pay down public debt that's been accumulated, or reduce other taxes, like labour taxes or corporate taxes. It's true that transferring money to the government and getting the government to spend it involves administrative costs, but we usually hope that they are small enough to ignore. So from an efficiency point of view, we're interested in this pre-tax profit amount and comparing it with the previous example. But if you are a regulated firm, you can bet your bottom dollar that they're going to be focusing on this thing, right? If you're an accountant for those firms, then the tax is very much, the fact that we're taxing here is very much affecting their bottom line after-tax profitability. So this speaks, starting to, we've not done everything yet, starting to speak to this issue of why firms and households, for that matter, don't like taxes. It might be efficient overall, but it's taking money from firms and it's giving it to the government, which you can't expect firms to like. Yes?
That is still a political economy-wide. No profits are going to be private enterprises.
I mean, I think that is a sharp semantic point. I think that calling it net probably clarifies what this quantity refers to. But I think what you're getting at is that the distribution of profits is different, so should I call it economy-wide? I call it economy-wide because I want to indicate that I'm adding up across all the firms in the economy. I think you completely understand the issues here. Any other questions? Are you with me? Good. Last example, my favourite one, because it's a bit devilish. It's the cap and trade scheme, okay? So instead of a tax, we're now thinking about the other wage price carbon. So the regulator starts with a total of capital N allowances, and we're going to assume free allocation. So the regulator is going to give each firm a set of allowances, and unlike example 2, the non-transferable quota, this is a transferable. So this is an emissions trading system, so the firms can trade with each other. I said let's assume that every firm gets 10 allowances for free, and I also asked you to assume that the allowance price is 10. So with that information, I asked you to go through the table as before. So let's do that. So what have we got for optimal output or emissions? 0. 5. Good. Total production profits, in other words, before permit revenues are taken into account. 0. Did anyone do this wrong? Pardon?
25?
No. $75, 200, 375, not 475, sorry, this type. And then production plus permit revenues, so 100, not 199, 100, 125, 200, 325, okay? Microsoft. Oh, it's one of these things. Fine, we'll do it up here. So, economy-wide emissions are 30. Economy-wide production profits are 650. Economy-wide production profits plus permit revenues, well, that seems to be 750. Okay, so there's something weird going on here, but just wait. I know there's something weird going on here because I'm trying to trick you. Okay, so we have, as with the tax case, we have a modified function. We have the norm. I don't want to write that. The normal part of the profit function, ax minus x squared. We're not paying a tax here, but we are requiring firms to pay if they want to undertake a net purchases of permits. Okay, so we add this plus p n minus x, okay, where n is the initial allocation and x where it ends up producing. Yeah. So if the initial allocation is larger than what it ends up producing, it has a surplus of permits, it can sell this at price p, and that's why this thing enters positively. Yeah. And vice versa, if it ends up wanting to produce x more than n, this thing ends up being negative. We do the same differentiation. It will help us to multiply out the brackets, right? And we still want to differentiate this again. It's going to leave us with a minus 2x. And now look, this thing drops out, right? Because the x doesn't feature. And this simple piece of high school mathematics contains the very important point that initial allocation doesn't matter for efficiency, right? That's literally what's happening here. Sort of, that's conceptually what's happening here when this thing drops out of the derivative. Okay. But this bit is still left, so we've got minus p. Set that equal to 0, and we're going to end up with a minus p over 2, yeah, which looks almost the same as a minus t over 2. Yeah. So when I told you that suppose the permit price was 10, just as it was in the tax example, then it should be no surprise that the outputs you get is just the same, right? 30. And the production profits before permit revenues is 650. So if I compare this example with the tax example, then we can see that these two quantities are just the same, yeah? And so we have made in this problem set again the point that was being made in mini lecture 7.1, namely that you could do this either through a tax or an emissions trading system. We're operating under perfect certainty here, so they're both equally efficient. Okay? That's that point coming out of the problems. But there is something something wrong with this problem? Who can tell me what's wrong with this problem as I've constructed it? It's a deliberate mistake, trick. Yes?
I'm not sure if this is it, but everyone has the same marginal cost, so you don't really have someone with a lower cost producing less emission and selling their permits.
So if we're satisfying the equity marginal principle, everybody should have the same marginal cost after a policy.
Let's say if their cost curve, like the steepness of it is the same, and you're allocating the same amount to everyone, would there still be trade for the permit?
Well, because the firms have got different productivities, they want different amounts of permits. And so with an initial free allocation of 10 to each of them, they will trade with each other up until the point where they don't want to anymore, which is where their marginal costs are in effect. Yes?
Could it be that there are more permits than there are emissions?
Yes. Bing, got it. What needs to happen in a market?
The price cap as well, or supply be constricted.
Yes, you're one step in, but what in general in any market, what needs to
Demand
happen?
equals supply.
Yeah, supply has to equal demand. But this is not happening at the assumed price of 10. There are two things in the table that would start to, should be ringing alarm bells when you were doing this, or you should be thinking, has Dietz made a mistake here? It's like, why am I doing this? The first is that I gave out, the regulator gave out 40 allowances, but the firms only want 30. So the market hasn't cleared, supply doesn't equal demand. The other slightly weird thing that's going on here is that economy-wide profits plus permit revenues is 750. That's 100 more than 650. Now that can't happen, right? Because one firm's permit revenues are another firm's permit costs. So they should all net out, right? There shouldn't be any difference. So this is just wrong, okay? And how can we make it right? You basically said it already, Arthur. Why don't you say it again?
So the regulator can either kind of reduce the supply of permits, or they can kind of change the price. Those are kind of the two angles that would, in theory, arrive at.
Yeah, so the way I would, you're right. So if the regulator really did, well, no, if the regulator can choose how much, the level of emission. I mean, this is the first and most important part. The regulator chooses how much it wants to emit. The market decides what the price will be. The regulator will probably have an expectation of that based on what it thinks demand is likely to be, but ultimately the regulator does not choose the price in the cap and trade system. The market decides. So let's just suppose then for the moment that we're sticking with this supply of 40. We want to use the market clearing condition that supply equals demand to figure out what price would emerge if there were 40 permits there, right? So we could do that. So start by doing it, just do it diagrammatically to get the intuition first. So let's do some supply and demand. That's fun, isn't it? Right. So we've got supply and demand, we've got price, we've got quantity. Now, what does a permit supply curve look like in a simplest cap and trade system? Got lots of arms waving in different ways. Yes?
Just not vertical. Right?
It's vertical, right? It's completely price inelastic, right? It's just been set at 40. It is what it is. Demand curve for permits, however, is going to look more like a normal demand curve, right? It's going to be downward sloping. Right? We want fewer permits at higher prices, and we want to find the price where these two things are equal. That is the equilibrium price in this market. That's what we want to try and solve. Okay, so we want to bring together information about supply and demand. We know what supply is. It's equal to 40. We then have the slightly trickier task of constructing an aggregate demand function. How would we do this?
So there's some deformations or something.
Yes, we do horizontal summation. Okay, you've probably done a bit of that in GY427. You must have done that in micro. Okay, horizontal summation in this case literally involves doing, we know that demand for permits is going to be A minus P over 2 for each firm, right? So we just, for each firm. So horizontal summation involves saying, let's take the sum over firms I of AI minus P over 2, which is going to be 10 minus P over 2, plus 20 minus P over 2, plus 30 minus P over 2, plus 40 minus P over 2. Okay. That's going to wind us up with 50 minus 2P, okay? And that's going to end up with, we're going to set that equal to 40 from the supply, right? So we're using the market clearing condition, okay? That's going to end up, give us with a bit of rearrangement of 2P equals 10, P equals 5. So just use the market clearing condition that supply has to be equal to demand. We know what supply is. We construct the demand function by horizontally summing, by aggregating the individual demands of the 4 firms. We know what they are from solving the previous problem, so we just add it all together and we get a price of 5. And that makes sense, doesn't it? Because it's a lower price than the one in the example, isn't it? And it should be, because there are more allowances than there is demand at P equals 10. So we would expect it to be lower. I know horizontal summation gives me Okay, good. And really, I think that tells you everything that you need to know about this problem set. So let me just recap the main points. So firstly, all the policy examples involve firms making less profit than they did when they're not regulated. So the first thing that this problem set shows or assumes is that reducing emissions is costly. The second thing that the problem set was intended to show was that you could deliver a larger emissions reduction at a lower cost using either a tax or cap and trade compared with command and control. Okay, so it was just a problem set to reinforce the ideas in Mini Lecture 7.1. But we showed how the distribution of costs, the incidence of the costs on firms was different between the tax and cap and trade, which speaks to the points in Mini Lecture 7.3 about why taxes and cap and trade can be equally statically efficient, and yet they have different distributional effects. And since the tax had a much larger effect on the firms than cap and trade with free allocation, okay, then we can see why regulated firms would prefer to have an emissions trading system than a tax. And I think that is pretty much all I want to say about this problem set. Any questions about it? Yeah.
If we would have an auction and sort of they would auction off efficiently, would we get to the same net profits as with the taxes?
So I love the fact that you've asked me that. I was thinking about whether I wanted to go down this road. Not everybody is going to love the fact that you asked that, is it? So if we assumed that, I can do it down here. So if we assume that we're in an auction situation, in this sort of super simple a textbook example, we would just say that the profit function equals ax minus x squared minus px, where p is the auction price. And in this very simple example with no uncertainty, the firms would just purchase what they need in the auction and there would be no secondary trading. Which does actually lead me to a point which is quite substantively important. Like, in emissions trading systems where there's an auction of the allowances in the first place, why would we see any secondary trading? The answer is that uncertainty comes along and creates outcomes that are different from what firms were expecting when they made their initial purchases, and that creates a secondary market. But in the auctioning doesn't really in a way work in this very simple example because the firms will just treat it like a tax. They'll just go and they'll purchase permits at P, and P will be given by the equilibrium condition, and there'll be no trade.
In those auctions, aren't brokers also allowed to participate?
Yes. Well, I'm not sure what. Yes, they certainly operate and dominate trading in the secondary market. Right? Secondary in the sense here of trading of allowances that are already in circulation. They probably. I'm not entirely sure whether they also operate in the auction market. They might. So then they would be going in and they would be bidding based on an expectation of what they could then go on to sell to firms for. Okay, let's take a break. Let's take a 10-minute break, a little bit shorter than a little bit earlier than our usual break. Let's take a 10-minute break and start again just after 3 o'clock.
So fast.
Maybe people over it and then you like
GY427, so I'm going to like lecture and seminar today ago.
and I went, oh, hey, like,
Okay.
I mean the map is
The special one is good, no?
Also, it's 200 hours total, 10 hours a week for work.
Shocking hard.
Crazy, because I don't, and they're longer term. Like, I kind of expected these to be like 3-month projects, but they're all no, I mean, they're paying super well. It's actually
There's the sign-up sheets. Is it making its way around?
Yeah, it was.
Somewhere over here.
Yeah, nice. We got an example.
It does look pretty crazy.
it was good, but like by the end of it, I just
Oh my god, it breaks a lot.
You Helen, what's your
I was telling you this. Oh, it's super good. Yeah, it's super good.
That's
I'm gonna tell you this after my last meal with my sisters and my trip. We were like, let's go. Let's get some. Let's get some wine. So we got it, but then
Not really.
none of us really understand because obviously in Spain people are kind of speaking Spanglish to you. Like my sister's partner and my sister both speak Spanish, but like they were the person dropped off the steak and they were like, oh, like don't touch like hot. Okay, and then but then like I took a piece and I'm like, oh, it's not hot. It's actually like quite cold. And we were sitting outside and like we were like, it's kind of warm. But I was like, it's not that hot like at all. But we were like, it's pretty rare. Like it's cold. Like it's so pretty rare. And then we finish it, and then she comes out with with a hot plate. We were supposed to cook it all the time. So we ate it like they basically cooked the outside, so it was like incredibly rare. But like obviously the hot plate was so you can cook it to your desired like level. But so she literally comes out with a hot plate and she was like, and we were like, oh. So, but she brought it out like 10 minutes later, so we were like, yeah, but like we
The governing table of the guy is a very fine listener. He has been a good surprise for me. Nothing to do with
No, no problem. So I can go back to the
reach out.
that drawing.
But you should have a look at the course.
Go back and
middle,
go back and
the slides are very explicit. I feel like Steven is very, very clear watching the slides. He's ready to get faster. What's your theme exactly? Like, okay. Yeah. You have data or it's an external project or? And it's publicly available? Amazing. But it was your idea in the first place, or it was one of the external projects? That's super interesting because I think if you've got some good data on trading, like you can really do a lot. Yeah, it's gonna be cool. It's probably also like a type of data that not a lot of people have looked at. So. Yeah, I'm sure. But in this, there was this article about air pollution in India, where they had like the trading data. I think it's really interesting. Yeah. But I missed. Unfortunately, I didn't take that elective. The one with energy one. Yeah, everybody said class function is the best class I've ever had. And I was quite unhappy with my choice.
I need to hear about
Class I've ever
but
had.
it's like
Stop telling me that.
They get to do
So I took it's called Innovation and Technology Management.
yeah.
It's a department of management. But I asked you guys.
Exactly. I know.
Very interested in. Very structured. But in the end, it was the best. In the end, it was the best. And was an essay about presentation technologies. So I was super interested.
I bet you wish like that.
I was very happy by the end of it. Also, the seminars, he got people to present, nobody was doing any work. Yeah, it was not for Mark, and people were doing something that GPT and just And there was a very long reading list. But I think it would be, super selective. So the one on the GY427, they run the price. Same. Yeah, it's super small. Yeah, he's very good with that. Yeah, because even applied in method and a lot of podcasts, which was very interesting. Actually, it was lots of stuff like nothing to do. Yeah, and also whatever the Nobel Prize, women in the one from Esther Duflo, like equality with women.
We're going to Mad Cats on Thursday.
All right, 2 minutes. 2 minutes.
We're gonna go on Saturday.
Yeah. Yesterday I was completely confused. Actually, like every equation I was like, what does that mean?
So we went.
And also even the Gupta review, like he. What does it say? Like, oh, we need to finish. What?
Your eyes,
Yeah.
Do you know what it is? It's not that I think it's necessary.
But that's I had the same because the Das Gupta review is criticized for being too like right. It's not good for the makes it he's trying to same language. I was completely lost.
You get paid as well.
I'm gonna be brave. I'm actually so extra.
I would definitely.
I'm just telling like now it's like go like in the water.
This morning.
A little bit of show up.
You're British, like you guys don't have a sense of temperature.
I would think it would be the same thing. I feel like I think I'm trying to look at a pub, which is like looking at a pub and this.
Again, so the second problem set is similar to the first one. It is focused on the capital trade scheme. It is intended to just drive home some of the price discovery concepts just a little bit more. And it finishes with asking you to think about factors affecting the evolution of prices in the real market, for which I will show you a time series shortly. So here we have not 4 firms, but 10 in the table. You can see for each of the 10 firms their profit with and without a marginal ton. So this example is more compatible with the idea that abatement is separable from output, but it could be that the difference in profit with and without the emission is just the difference in producing, but it could also be because they're paying abatement costs. Okay, and we are going to consider how these different firms would behave in the permit market. So the first question is a simple one, so we're going to start by focusing on firm A. I'll just highlight it there. So I asked you, what is the range of allowance prices that this firm should be willing to pay to emit an additional ton of CO2 based on the information in the table? And the answer is?
Anything between 0 and 3544?
Yeah, exactly. Up to 3544, which would be exactly its point of indifference. But if it were, say, $1,000, if the price of a permit were $1,000, it could still buy that permit and make $2,544 of profit. So anything up to 3,544 would be right there. Yes. So question 2 would be, so we're imagining that there are 6 permits out there, each amounting to a ton of CO2. Given what we know about firm A's willingness to pay, question 2 was, can we think of a firm that would be willing to sell to firm A? Are there any firms that would be prepared to sell to firm A? Yes. Yeah. All of them except H would do it. So we could just pick E, for example, the easiest example. So E only makes $8 of profit from producing an additional ton. So it could sell to firm A at any price above 8. Firm A would be willing to pay anything up to 3,544, and if it were somewhere in between, there would be a gain from trade. So they would exchange. And now, if we were in a world where there was just one bilateral transaction, you might be thinking to yourself, well, where would the price lie between 8 and 3,544? Well, if we're not in a competitive market here, then it would depend on the bargaining power of the 2 firms, right? But as soon as we're in a competitive market with lots of possibilities to buy and sell, bargaining power goes away, and firms just take the prices given. That's how to think about that question of where would it sit between 8 and 3,544. The answer is, we don't know. If this is just a single bilateral transaction, it becomes a question of bargaining power. In a real market with lots of transactions, we would hope that nobody would have bargaining power, and then the price is just given by way of supply and demand. Very good. We'll go through this problem set a bit quicker so we can talk about the last question more. So I think we basically already answered 3, okay? By how much total profits increased thanks to this trade. The answer, if the example were firm E, it would be 3,544 minus 8. Firm E is foregoing profits of 8. Firm A is getting 3,544. There'll be a permit price exchange there, but the price that firm A pays goes to E, so that nets out, right? That was the point we made in the previous example. So say it was 1,000, it would be 3,544 minus 1,000 minus 8 plus 1,000. The 2,000s would go out, and you would be left with 3,544 minus 8. And you could do that for, as you said, you could do that for any firm except firm H. Firm H is the firm that wouldn't sell to firm A because firm H makes so much profit that it would not give up its allowance to emit to anyone. It would want a price of more than 9,149, and nobody is prepared to sell at that price, which I think is the answer to question 4. Yes. Okay. Now the one that we want to spend a little bit of time on is this price, speaking to this price discovery point, is what would the equilibrium price be if we give out 6 allowances? So what would it be? Let me bring the table back up in case it would be helpful. Yeah.
Between 893 and 2,152?
Yes, exactly, and very precisely stated as well. So the answer is between 893 and 2152. Okay. How do we get there? Well, we're doing exactly what we were doing in the previous problem set. Okay, so we're trying to equalize supply and demand. We've got a vertical supply curve at Q equals 6 allowances. We want to construct an aggregate demand curve. Here we're just adding the different, adding these values in this column basically. So we start at 3544 and then it kind of goes like this, 3, 4, 5, 6. And this is 2152 and this is 893. So we are looking for the point at which the demand curve intersects the supply curve. Now, it's lumpy, the demand curve in this case, so there isn't a unique point at which they cut, which there will be in a market with more participants, okay? Or where we give each of the participants a continuous individual demand curve. So we can't actually say exactly where it would be between 893 and 2152, but that is really just an artifact of this being a very simple example. Logic is still the same. We're looking at for the intersection of supply and demand. Now, hopefully that's all clear. What I really wanted to spend more time on in this problem set is this last question. So this is going to be a pair and share exercise that we can do now. So with your neighbours in the room, I'd like you to spend 10 minutes discussing what you think would influence the price of an allowance in an emissions trading system. And I would like you to try to separate them into short-term and long-term drivers. And to make this exercise a little more tangible, I'm going to show you some real price data. Okay, so this is a time series for the price of an allowance in the EU ETS, going back to the very beginning in January 2005. And it's not quite up to date. I couldn't get an up-to-date version that runs up until January 2024. So here is a time series of all the prices. I'm not going to give you any indication up front of what might be causing these fluctuations and trends, but I want you to look at this and see if you can think about the sort of things that could have been happening to cause these sudden decreases, increases, upwards trends, downwards trends. Okay, so 10 minutes with your neighbours, see if you can come up with some ideas about what could drive the price of an allowance in the EU ETS.
Yeah.
We do like
I mean, there's obviously a very large spike now.
every time it's about
So
talking about different
like, I guess
In 08, it was during the financial crisis, basically, production went down, GDP went down, and then there was less production.
yeah, it's kind of fun. I think one size is
oh yeah, in 20, oh I bet it's
Also, the regulators of
oh yeah.
maybe that's 2 or 3 or reduce
A couple like very
they reduce the number of alarms.
yes, what
there's no carbon price. Yeah, so that is a carbon load. So you look at a carbon load. That's why they have CBAM. You can really see the,
The innovation of it.
yeah, some area is actually the emissions.
Anything like any kind of like
Would you say something about like productivity here of like You fix that actually.
Definitely.
I'm having a hard time.
More of a downward companies are to be at this point.
Projects that are starting. I think there's a part
Right here, like the Ukraine-Russia
Yeah, but also you got so much from the region.
It's like US.
And after the surgery, how long do you think?
Policy changes, like you have
Really?
It's just like implementations of
But here, I don't think it's insured either. Like not.
I don't know how.
Too late.
How much are they? How much are they? I mean, like we're talking about, do they have it like every 3 months, or is there?
Yeah. Like, is it not true? Like,
Right. No, I think it definitely is a lot. Yeah. No, it definitely is a lot of price. Yes. That's what I'm saying.
Whatever the lady said.
There's an insurance cap to get it increases at a yearly rate.
Right. That's it. It's like stock shares, right?
Yeah,
It's like
exactly.
you issue more shares. Yeah, okay.
Like I wonder if they that way. Yeah, be a big deal.
PlayStation download and use somehow or something.
That is good. I did the mini lectures. I didn't do that. I can trust them.
That's not direct.
Is it direct? Not all the markets are.
Yeah.
They're like companies.
Stay here for.
Regulator. You should talk to the up and down. Honestly, the biggest thing is even client relations. How they do it because exactly.
You know what
So many problems. And I was like, no, I would like a phone. Give me a phone.
I can tell it's you in a physical box, which is really good.
Are you a real person? No.
But I was talking to companies because I'm so frustrated with obviously like people in the around like I know we have a box and get a certain area. So you have a lot of different
Apparently, out of nowhere, it becomes like a NBC. Up to them,
the others? Outback from the others?
I know them.
I want to get money.
It happened literally today.
I went through, because you know, at one of the 4 days.
Oh, he told you more than he told me. Wow.
That's a big shot.
There's full showers. I can.
One of the guys. Brighton. Really quick. It's not. They don't have any. I also think it's a bit empty.
Well, I mean, she also makes a ridiculous amount of money, so her gym is. She has like the shittiest price on the side of it. I'm like, hey, that's
like shower bill.
yeah. And also, there's so much.
Right, and then you're like, yeah.
Well, that's the thing about Equinox. They have really expensive products in all also. But like, she has a sink.
Which state?
Typically at her Equinox in New York, which is the one like right near Cat Stella Casar. It's so much nuance about it. Apparently, there's like a whole this specific equinox that we've heard from multiple people, and it only happened in like the men's room. But there's like apparently a so then my sister found out, so she's changing.
Yeah.
So she was about I just
But I mean, and they're reluctant to hear what they used to say. So she's reluctant to be like,
Instead of finance, it might even be better than.
you gotta give up some countries to.
Washington might be added in.
I think it's very tough.
Some might say that about London.
And let's also see whether we can actually link some of the explanations we come up with to some of the things going on in this time series, bearing in mind that if you want to do this properly, you would want to do some time series econometrics. We're not doing anything that fancy here, right? We're just going to do some hand waving and broadly link some of the things we're seeing with some of the drivers we talked about. Okay, let's get started. So over this side of the room first. One factor that you think is affecting prices?
When we thought that the huge surge, like in the start of 2021, was because the economies were reopening after COVID, and maybe there was more emissions. And
yeah, so the specific thing we're thinking about here is the pandemic. The pandemic we might think about as a shock, indicative of a broader issue here, which is economic growth, right? So, and that's definitely one of the things that's going on here. So, when economies grow, they produce more. Production is proportional to emissions. So when they're growing, that's going to push up demand for permits. If supply is, that's going to push up prices. Are there any other places in the time series where we might think economic growth is having a big effect?
There's a 2008 crisis.
Yeah. This bit. Not that bit. We need to talk about that separately. Something extremely weird happened there. But this general downward pressure on prices through the late noughties and first half, most of the 2010s, is the generally depressed state of the European economy. So yes, absolutely. Okay, so that's one, economic growth. I'll come back to you. I want to go over this side of the room. Anybody over this side of the room can think of something? Yes?
You've got phases where it just restricts supply.
Perfect. Where do we see that most blatantly?
21, but the introduction of the new phase.
It could be, but there's an even more striking example of that, which is what happened here. Let me tell you about what happened here, but first of all, let me note this down. So we might put this under the broad rubric of design issues. When I mean that, I mean market design issues. And you may or may not be aware that emissions trading systems often work in phases, so that the regulator defines periods of time as being different phases. And it may also be the case, and I'll explain this a bit later, it may also be the case that you're not allowed to arbitrage between phases. In other words, you can't bank permits in one phase and use it in a future phase, or borrow permits from a future phase and use it in a current phase, right? Now, it so happens that phase one of the EU ETS was hermetically sealed, if you like, in that way. So in phase one, which ran from January 05 to the end of 07, the allowances that were given out for phase one could only be used for phase one. It wasn't possible to bank them for future use. So phasing partly explains what's going on here. And as you said, there was also a change in phases in January 2020, going from phase 3 to phase 4, if I've got my numbers right. And that seems coincident with an upturn in prices, although there's a bunch of stuff going on here. But the phasing explanation doesn't completely explain what happened back then. Does anyone know what additional thing we need to bring in? Yes.
I'm not sure if I remember this correctly, but did they reduce the number of outstanding permits in 08 because of the downturn? That explains the drastic increase there, like the
No, but if you did withdraw permits from the system, you would put upward pressure on the price, yeah.
Did they reintroduce grandfathering like for a very short period of time?
No, it was almost all grandfathered during these early phases. It's a good thought, but no.
I'm not sure if that's driving that phase, but like why the Kyoto thing, they could sort of import permits.
It's also a good thought, but it's not what's going on there. Now, remember your supply and demand. What would it take for P to be 0?
Demand dropped.
You could do that, but it's not what happened here.
Oversupply.
Oversupply, right? So what happened? So bear in mind that this was the first phase of the EU ETS, the first large-scale ETS. It was a bit of experimentation. In 2007, information reached the market that there were too many permits in circulation. Basically, that supply exceeded demand, and that firms did not need to acquire any permits there was no scarcity, basically. And so when information reached the market that was the case, and given the phasing point you made earlier and the inability to bank permits or arbitrage to future years, the price just dropped to 0. Which brings us to our third rather obvious point, which I think a number of you have been expressing one way or the other, which is that the stringency of the cap, okay, very obviously affects prices. And in our simple micro world, this just means that I just move this supply function left or right. I'm clearly going to influence the price. This way is more scarce. This way is less scarce. Until I move it so far that the demand function hits the x-axis and the price is 0. Yes.
But how does the EU decide how many permits to emit? Is like a dynamic process responding to market?
Yeah, we'll talk about that a little later.
Okay.
But basically, the general idea here is that the EU makes international commitments through the Paris process, and then works backwards from there to think what the cap level will need to be in the EU ETS. The EU ETS being one of its main instruments to achieve its Paris Agreement commitments.
Yeah.
I think maybe the flip side of this is market transparency or market efficiency, and more specifically sort of uncertainty, because if it would have been like in a perfectly efficient market, it should have been 0 all the way through.
Yeah. So exactly. So what it was there was, to begin with, information wasn't perfect in the market. Information wasn't flowing freely about what people were emitting, the early days, new systems. And so it was only here that there was discovery, and it wasn't overnight either. I mean, it was a sort of dawning realization, as you often get in like stock market crashes, where like, are we really holding on to worthless assets? Maybe we're not. Oh yeah, we are. Are we really? Oh yeah, we are. And then that's what happens. So 3 very good points already. Let's move on.
Yeah, just to cover. So then the jump back up is the beginning of the next phase where they reissued.
So
okay.
Complete. So reset. Right. New cap. New issuance of allowances. Actual scarcity, as evidenced by positive prices. but then we had the global financial crisis and economic weakness everywhere, particularly in Southern Europe, though, and therefore prices were very low. And throughout the whole of the 2010s, basically, the literature was worried about low prices. Trying to work out whether this was just kind of what you get in the cap and trade system, or whether this was a bad thing. So if you do kind of dip into literature from back then, you'll see a lot of that kind of discussion. Sort of feels a bit kind of old hat now, especially if any of you have been following what's been going on in the EU ETS in the last 2-3 weeks, right, where there's been a lot of worry about high prices and politicians making ambiguous and unhelpful statements about what they might like to happen to the system. But we're in a different regime, that is clear. Okay, other stories here. Yes?
The decrease in Jan 2024 could be a rollback of global climate policies?
Well, in general, definitely, we could. I mean, so this is kind of climate policy in the very narrow sense of regulatory decisions about scarcity. But we can definitely talk about broader climate ambition or policy here, right? So, carbon markets follow what goes on, for example, in the UN negotiations. And they might not jump as a result of what is or is not successfully agreed at UN summits, right? Because it's not directly germane to the price of a permit, but it's been demonstrated that they do move, right? And that both in good situations like the Paris Agreement, and I said we weren't doing proper econometrics, but you can see sort of the price going up during the period leading up to Paris, right? But we might also see drops when the opposite happens.
Could that be attributed to a Trump election?
I don't think that would move it as much. I think we haven't talked about what's going on here enough yet, but it might move it a bit. Because you see, a Trump election doesn't directly affect either the price of an allowance in it doesn't directly affect the cap in the EU ETS or directly affect economic activity in Europe, but it definitely has indirect effects, particularly on the latter. Yes?
Maybe expand the sector's coverage, so that explains the surge of the price, because more demand from different sectors.
Yes. So we can, again, we'll talk about this in the last part of today. But when you design an ETS, you have to decide which sectors you cover. They never cover all the economy, right? You usually start with electricity and heavy industry. When you add a new sector, and it's got different marginal abatement costs than other sectors, it's going to affect the price. Yes. Yeah.
For things that have more like long-term impact on marginal abatement costs, so sometimes energy prices or technology improvements.
Yeah, so great. So energy prices are going to affect allowance prices, but we need to talk about the mechanism here because it's not immediately obvious. So what is can I ask you to elaborate on the mechanism here?
Yeah, so if like energy prices go up, then it means you're going to prefer to abate because like the marginal abatement cost is kind of going to decrease because it's more.
I think we need to talk about what you mean by energy prices, right? So it depends on which energy carrier we're talking about here.
Yeah.
So let's use as an example Russia's invasion of Ukraine, which led to a surge in gas prices. Now, how would a surge in gas prices affect the price of an allowance?
Yeah. Okay. If you go to the lower, dirtier fuels like coal as a result of high gas prices, then you're going to be emitting more, and then you'll need more allowances, and the prices can go up.
Exactly. So that's a really, it's not in general. We're talking about substitution between fuels here, and this can obviously go in different directions. But what happened with the Russian invasion is it had a specific effect on gas prices, pushed up gas prices induced a bit of substitution away from gas towards coal. Coal is dirtier than gas, so per unit of energy supplied, you need more permits to cover that. That's going to produce, it's going to push the price up. That is definitely happening in 23 and 24. And it's also, I mean, you'll notice also just a lot of volatility. It's also contributing to the volatility because it added to uncertainty. So absolutely, yes. Yes, and then I'll come to you.
I mean, I think this is tied up in the pandemic as well, but the inflationary pressures coming out of the pandemic, in terms of that, would that have had a substantial effect on the price?
I mean, inflationary pressures are obviously bound up with growth. So the question is whether inflation, I mean, I think this is in nominal prices, this series. Okay. So therefore, inflation would be interfering here. If we were to put this in real prices, I'm struggling to see what the mechanism would be. But it's possible you could tell an indirect story about what inflation is doing to demand for natural goods, or what inflation is doing to interest rates, which in turn is doing to activity. Right. Yeah. I promised I'd come to you again.
Back to the energy prices. Wouldn't there also be a second channel there that higher energy prices usually lead to lower economic growth, which would then again deflate? So that's like a counteracting channel.
Exactly. So effect of prices on output. Yeah. I think, in fact, the former factor was the more important one, but you're quite right. There would be a sort of an income effect, if you want. Yes?
Thinking about the longer run, if you have higher energy prices for fossil fuels, would that not lead to more investment in things like renewables and change the mix of the energy grid towards more?
Yeah, and so it sort of brings on the point of kind of clean energy investment and sort of technological change, which was a point I think you were making as well. So we can add that. So as the price of renewables comes down, for partly due to the ETS, but also due to other policies in place, not just in countries within the ETS, but also outside it. That's going to affect the cost of the outside option, which is going to affect the cost of allowances, clean energy prices, technology. So yes, absolutely. And yeah, did you want to?
Yeah, I was kind of coming from a similar point, more in the kind of cost effectiveness of like other abatement technologies. So if you had a big breakthrough in CCS and suddenly it became much cheaper, then you wouldn't need as many permits per se.
So let's just put a few so renewables, CCS, etc. as examples of this. So technology dynamics among alternative clean technologies. Yeah.
I'll argue the carbon leakage is a driver because it impacts the production function of the firm, because if they move to manufacturing outside of EU, right, then less demand overall.
Yeah. That is something, I'll put it here, that is something we're going to talk about in 2 weeks' time. So this is, we're going to get into issues around competitiveness, leakage, outsourcing, that kind of thing. It's, I mean, it's sort of like economic growth. The mechanism here is aggregate demand, isn't it? But absolutely, yes, yes.
Maybe already captured under broader climate policy, but if you have sort of overlapping policies, for instance, if you have a command and control policy, then you have a waterbed effect.
Yeah. So, and this is kind of similar to design issues, but because it's not about ETS design per se, because it's about the design of policies which overlap or relate to the ETS, we probably should put it in a different bucket. Yeah.
We talked about, as a short-term driver, weather and energy consumption.
Excellent. Yes, absolutely. So you have, say, a cold winter in Europe with, say, no sun, no wind. What do you call it in German? Dunkelflaute, something like that? Dunkelflaute. Yeah, something like that. Then, you know, it's people need more home heating. There's less power from wind and renewables. It's going to push permit prices up. Similarly, when you have a good old-fashioned British winter, as like the one we've just had, right? So quite mild, often windy. You know, it's yeah, mild. Yeah, for real. Yeah. Not by your standards, no. Then you know that there's less demand for gas for home heating or for electricity for home heating, and there's more renewables output. Okay, so and you could think about other weather patterns. But you know, weather is not a massive thing, but it's probably explaining some of the stuff that's going on. I'll take one or two new hands and then we'll sort of wrap it up. Yes.
Can it be prices of raw materials, like I don't know, metals that you use for producing the technologies or coal?
Yeah, definitely, and it's another factor that's sort of affecting demand. Yeah, so sort of raw materials prices, sure. Yeah. Because the ETS primarily covers, you know, industrial sectors. These are consumers of raw materials. If there's some kind of raw materials price shock, then that is going to affect their demand, their output, and their demand for permits. So, okay, last one.
Climate change impacts may lead to behavioral changes, like people in demand less carbon products and services.
Yeah. So no, absolutely. So there's the consumer side of things, which you know feeds through into the allowance price through the effect it has on how much demand there is for the goods of sectors that are covered. Okay, so that is so we've talked about a range of mechanisms here, which basically go through how much the EU ETS sectors are producing. Wider economic conditions like pandemic, global financial crisis, specific issues like upstream input prices, downstream consumer demand. You know, if everybody gets into using less electricity, reduces the demand for electricity, drives down permit prices, and so on. So we've got a mixture of wider economic issues and design issues specific to the EU ETS or to the policy landscape that surrounds it. Okay, because it is ultimately carbon is only valuable because the regulator makes it scarce, right? Otherwise, CO2 as a commodity is worth nothing because it's a global public good or bad. So that's why it's probably fair to say that it's more policy dependent than most other commodities. Right? We would usually think of it as a commodity and think about it alongside other commodity markets, but most commodity markets are only indirectly dependent on policy decisions, whereas this one is very directly dependent on policy decisions, above all, not only, but above all, about the scarcity of supply, in other words, the level of the overall capital. Good. Talked about everything I wanted to talk about. In one of the further readings, the Sato et al. Paper, there is a sort of a version of this time series with some annotation talking about specific things that happened along the way here. And so if you're interested in digging deeper into that, then I would go to that reading. It's in the further reading list. Okay. This is a great time to take break number 2. Okay, so let's have another 10-minute break and start again at 4.
Yes, usually like 2 hours.
I don't know what that means. Why is it so today?
61 is going to be 13.
Please don't. And then
63 is fine. I know you're sick, aren't you? Are you just going out casually? So, present 5. I feel like I haven't hung out with like we're like so
yeah. You're going.
No, I'm so excited. Maybe actually. I know we were just like too embarrassed. We did like a circle fight people for a second and we're like, this is on us, like, it's fine. And then we were left alone for a while. And this dog just sat there for 2 minutes and just why is it disintegrating? It's actually so cute. I've never seen bro, this looks like an AI like depiction of like what a kid would draw as a dog. No, who owned this fucking dog? He just like sat there and just like stared at us the entire time. It's just like it's a little dog. Like it looks like a big dog in the first picture, but like he's such a little dog. It's so funny. Every single cocktail had egg in it. Interesting. Well, that's such a good picture of him. Bass. One of Isha's coworkers. And he's so what? Why would you say that? Because you didn't know how else to say it. How to say, oh, I heard talking to someone in earshot. I heard your people are getting blown up. I feel like if you don't have the English to be able to say that as a normal question, then you shouldn't be discussing it with an He's lucky because he's so French and passed it off. Obviously, I'm not trying to be rude about it, but it is just like, I was like, that's a crazy thing to say. But I feel like it is really one of those things that's like you need to know your place, and even if you are trying to say things in a certain way, like you should be having that conversation. How is Keon doing? It's fine. It's like, it's so complicated. I'm just gonna watch some it's really, I mean, and I just heard that it's like obviously so many people have I've seen so much discourse online that people are like, no, many people actually the U.S. internal helped do you think that Trump is going to use that price for I'm just putting in more, this really lower. It's really, honestly, it's really. Yeah. Of course, it's like an. But I just hope he's doing okay because I think should I tell her to come out? And I said this to her, I'm gonna probably go to the Del Water down on March. It'll be my 6th time going to this. He's been like one of my favorite artists for a really long time. And the tickets aren't that bad, they're like $30. Wait, let me track her. And then do you want to get a plane after class also? Or do you have to go back? Immediately.
Yes, I can.
Why did I picture that so
Western town. Very down for this weekend, what am I doing this weekend? That's not true. Sunday I have.
We're going to
Close to London Real Station.
how I knew that.
Like it's east of us.
Yeah. Technically everything is east. Are you talking to that? Yeah.
I consider that east.
European.
Well, except anything is east to you. I'm
It's
like
literally it's N1, yeah, it's like it's in the name, right? But like because it's sort of like
I feel like Islington is more north. Yeah. I was gonna say it's pretty classy here.
That's true. Yeah. Okay, so you're shortish. You're definitely.
Yeah, I like that. I'm E1.
But like the transition.
Yeah.
Deep. Yeah.
Yeah. I'm technically in Spitalfield, but even then, I feel like quite similar to Shoreditch.
But then like it's nice, but it's also
yeah,
but it's east, right? Like, like that's the funny thing is like it's north, but like the border from north.
Yeah.
But you can get
yeah,
that.
but it's, and you're so easy to get to Camden. That's what I'm saying. Islington is like my favorite. Maybe if I stay next year, I will definitely be moving to Islington.
Okay. So you're kind of like.
Well, we gotta conglomerate everybody.
It's a fucking nightmare to get a place.
I know. My friend said that she got hers like fighting tooth and nail from like a friend of like that this one place was free, and they like jumped on it months before they left the lease. So. Yeah.
That's true. I've noticed a lot of families.
It's like a nice middle combination. I feel like that there's still a good amount of young people, but it's not. Yeah, exactly. Yeah. It's still a mix of everything. It's not just one person.
Like I think we're in Orangeburg, which I guess is a little bit.
Like how far does it take you to walk to the actual visit timers?
Draper's Arms.
I've never been to Albany.
My sister got very excited. She's into
What's the
what's the website? I will say that like.
Is it Supply 91?
Service 95.
Service 95?
Radio.
Like Yes. I do know I've seen like my sister is like obsessed with
Where would you live if you choose? Someone who you don't have to have unlimited money because I definitely don't.
Guys, we stopped. I need to please
So you were not doing such great advertising, Warren.
Yes, I mean,
wow.
How is 3 hours?
That would do.
Yeah, I'm in the Philippines.
So, this is carbon markets, carbon pricing, carbon markets in practice. Okay, so here are the learning outcomes. So to start with, I'm just going to, just show you the extent of carbon markets. Talk about things like coverage of emissions, price trends, revenues for the government, that kind of thing. Just so you get an understanding of how widespread carbon pricing has become and how far we've got. Second part is I'm going to put you in the position of setting up a cap and trade system. And I'm going to take you through some of the most conceptually interesting setup steps. Then, I'm going to switch. So having basically talked throughout today about the so-called compliance carbon market, so the idea that there's a regulator that introduces a cap and entities, firms have to hold emissions permits to cover their emissions. That is the idea of a compliance carbon market, and I'm going to contrast that with the so-called voluntary carbon market and carbon crediting. You're probably aware of this. You're probably aware that you can purchase carbon credits or carbon offsets when, for example, you take a flight. So we need to talk about the voluntary market because it is quite different to compliance markets. So we talk about how they relate to each other conceptually and in practice. And yeah, then I'll tell you more about how the voluntary market works. And you may be aware that the voluntary market is quite controversial. When I buy a credit, is it actually, are any emissions actually getting reduced? We'll talk about the worries here and the evidence. Okay. Okay? And in all of this, I'm really trying to go beyond what you would learn about cap and trade in a textbook, where it wouldn't go much beyond sort of efficiency under uncertainty and some distributional issues. This is more practically focused. Okay, so we'll start with carbon pricing around the world, and what I want to also say is that a lot of the slides that a lot of the visuals that I use in this mini lecture are from an annual report the World Bank produces called State and Trends of Carbon Pricing. It's in your reading list. If you want to know almost anything about the actual functioning of carbon markets, then it is a truly wonderful publication that is updated once a year. So I would go there and you'll learn a lot. I mean, it'll tell you nothing about the microeconomics of it, but it will tell you everything that the microeconomics textbook doesn't tell you, right? Including this. You know, how many places have either a carbon tax or an emissions trading system. So this is a map of it, including ETSs and carbon taxes that have been implemented, and also those that are sort of at the initial stages of implementation. They're somewhere along the legislative flow, right? So four key points about this map. So firstly, you'll see that there is carbon pricing on every continent. Okay, so if you had the impression that this was just something that we do in Europe, it's not true. Every continent has countries that are doing this. The second point is that, you know, it's not just industrialized countries. By now, there are a number of emerging market developing economies doing this. Examples include Argentina, South Africa. Okay, so it is no longer just industrialized countries. Third point is that while in many places this is done at the state level, the nation state level, there are also important places that are doing this at the subnational level. Most famously, in the United States, which doesn't have a federal carbon price, is most definitely not going to have one anytime soon. And that doesn't mean that carbon is not priced in the US at all. There are important states in the US like California, which do have a carbon price. So California has an emissions trading system. And China, before it had a national level ETS, which it now has, piloted this in a number of cities, which is what you can see these dots here. Okay? And Canada has also been doing this originally at the province level. So that's the third point. And the fourth point, which actually you don't really get out of this chart, but I can tell you, is that in terms of the distribution between ETSs and carbon taxes, it's about equal. Okay, so 37 ETSs and 43 carbon taxes, 80 pricing schemes in total. A sort of a fifth point, I guess, is that some jurisdictions operate more than one. So if you count all the countries or subnational units in this chart, you wouldn't get to 80, and you're wondering where I got my 80 from, apart from the report. The answer is that in some places there are multiple. We can talk a bit later about why you might want to have several in one place. Okay, so that is carbon pricing across countries. Any questions about that? Very happy to have questions. Yeah.
If you want to compare globally how efficient is carbon pricing in reducing CO2 emissions, how you do it, because one is a carbon tax, others have ETS, other emits. So can you put all that in a same unit or index and make countries comparable?
Yeah. So this presentation obviously tells you nothing about. I mean, the easiest thing to do would be to move from here to talk about price levels, because the price level in an ETS would be directly comparable to a tax scheme. and would give us a good proxy for stringency. The higher the price, the more stringent the scheme is, the more it's reducing emissions. Yeah. So that allows me to, I'll come on to that in a couple of slides' time. If you want, we can go a bit further and talk about how you might actually try to estimate the effect a carbon pricing scheme has had on emissions, but that raises some quite challenging statistical and econometric issues, which it's a bit beyond the scope of today, but if I get time, I'll talk a bit about that. Yeah.
How do two ETS systems operate within each other, like in China? There's multiple, like one with
Yeah, I don't, I mean, in general, they can cover different entities. That would be the easiest way for two ETSs to coexist in the same country, is that they actually just cover different sectors or different firms. I'm not sure in the Chinese case whether these city pilots have now been subsumed within the wider system, but there are ways in which they can coexist. And when we talk about the EU again later, we'll talk about the EU ETS 2 compared to the EU ETS 1, because we'll soon have two different ones. Just to make things even more complicated for you. Okay, so that is countries, this is coverage as a share of global emissions over time, okay? So, percentage of global emissions covered by carbon pricing schemes on the vertical axis, time on the horizontal, ETSs in dark blue, carbon taxes in red, emissions which are covered by multiple instruments in purple. And you can see that this has been going up. The jumps in this series are obviously to do with large new schemes coming online. So the first one is the EU ETS in 2005. Prior to that, there was just a tiny coverage, so that's one jump. I think the next jump is Japan introducing a carbon tax. Then this big jump is the Chinese national power sector ETS, and this medium-sized jump is an increase in the coverage of China's ETS. So generally, when you get a big new scheme coming in, coverage will jump. So first point. Second point is to draw your attention to where we are. So we're covering 28% of global emissions with a carbon price, which obviously an explicit carbon price, which obviously means that 72% is not covered, which is a problem. Last point to make, just this kind of small point, that if you introduce a scheme which has a cap, which is below business as usual and is probably declining, then by design, if that scheme doesn't change, its share of global emissions will go down, right? So in order to grow the coverage of carbon pricing globally, you need to either add new schemes or expand the scope of existing schemes. Otherwise, by design, coverage as a percentage will actually go down, because it's reasonable to suppose emissions are going up faster outside the schemes than within them. Okay, so that's just need to bear that in mind. But the main points here are where we are and how we've got there. Okay.
Do you know, like, any statistics? What kind of?
I hate questions that started.
What kind of?
I don't remember what I did on Sunday.
Okay, I'm so sorry. But what kind of share would there have been if the United States and the Russian Federation had implemented such schemes, like up from 28, like something like roughly?
So no. But if you went back to week 5, you looked at the US's share of global emissions, and then we sort of crudely said half of that would have been covered by a carbon price, you would get a sort of back of the envelope calculation for how much that would have added to global coverage. I would venture it would be in the high single digits, something like 5 to 10% jump. Okay. let's talk about price levels, right? So far we've talked about coverage in terms of countries and in terms of percentage of emissions. But coverage doesn't mean much if the price is low, because a low price obviously means that there's not a strong signal to reduce emissions. Can I come back to you in a second? Yeah. So this chart, same report, World Bank report, just lays out all the taxes and ETSs ordered in terms of increasing carbon price per ton of CO2 equivalent. So these are directly comparable, per your question. So the one on the right-hand side, the Uruguay CO2 tax, is the most stringent, not necessarily the widest coverage, but the most, on price terms, the most stringent carbon pricing scheme in the world. The EU ETS is up there, quite close. And then we go down the other end, we've got something like the Poland carbon tax, which is close to zero. Okay? There are a lot of things, a lot of implications of this. This is actually quite an important chart. Okay? The first thing is that, just to link back to what we've been talking about today, and also in Chapter 5, if we were reducing emissions efficiently worldwide, and we were therefore applying the equimarginal principle, we would expect the price to be the same everywhere. The fact that the price is not the same everywhere shows us that this patchwork quilt of coverage, individual countries and subnational jurisdictions doing their own thing, deciding on their own price levels or caps, is not leading to efficient emissions abatement globally. Because I could take a unit of abatement out of the Uruguay carbon tax and ask a Polish firm to do it instead and save a lot of money. Okay? And so on until all of these things were harmonized at a single global price. Until we have a single global price, we don't have efficient abatement spatially. Yeah.
Say for different places, they have different level of damages from emissions or something like that, or does that not matter?
So that is more like, so you're thinking, I will talk about this in week 10, that's quite quite an advanced thought, right? So you are thinking about a world in which countries are solving their own kind of private marginal cost and benefit problem, but that is not a globally cooperative solution, right? So you're inviting a comparison here of what a global cooperative solution to climate change looks like compared with different countries just solving their own problem. And we have been operating, and the Paris Agreement operates under the idea of a global cooperative solution, in which case all countries should be pricing carbon at the same level, equal to either the global marginal benefit function or the cost of the global carbon constraint, whether you want to think about this in a cost benefit or cost effectiveness sense.
Do we need to think about it only in nominal terms, or do we also need to worry about purchase power effects there?
Is that your question as well?
Yes.
I think for efficiency, it's probably okay to think about this in market exchange rates. I think that purchasing power parity would come into this if you started to worry about equity. I think that's the right answer to that question. Yes?
I have a question. If every country has their own prices in their market, for example, Colombia has carbon bonds. So I know, for example, that Singapore wanted to buy carbon bonds from Colombia.
Yeah.
But Colombian carbon bonds are like £5 per ton of CO2. Like, how will that work? Like, I mean,
Yeah.
I mean, in terms of,
that belongs into the credit. That's a part of the crediting market rather than the compliance market. Easy. It's a great question. easiest way for me to reply to that would be a bit later, basically.
Okay.
But in general, you know, one obvious way to bring prices close to equality is to start linking schemes together, right? So if you link two ETSs, right, then you will get one price out of it, right? So, you know, clearly a major issue here is the fact that all of these are more or less operating in autark, right? They're individual ETSs. You can't trade permits with other ETSs. One ETS might have a tighter cap than the other. You will get two different prices, okay? So that's one way. But even if you're operating, if you don't want to join ETSs or if you're working with carbon taxes, it's not ridiculous to think about attempting to harmonize tax rates, okay? We have these discussions, admittedly not usually successfully, about harmonizing other kinds of tax, like corporate taxes and value-added taxes across countries, right? So, you know, it can be a part of the international process to discuss the level at which, at least like a corridor, that everybody should be in terms of their price. Which, by the miracle of my brilliant lecturing, leads me to the next point, which is, suppose we wanted to define that corridor, or suppose more generally we wanted to answer the question, okay, what's the right price? Where would I get that information from? How would I answer that question? These are the prices that we actually have, but what's the right price? Where would I go for that?
Social cost of carbon.
That's one way to do it, exactly. We could turn to the marginal damage cost or the social cost of carbon. I haven't talked about this a lot in this course. We talked about it much more in GY426, but there was a little bit of mini lecture 7.2, I think, where we talked about the economically optimal amount of emissions abatement being their marginal benefits across marginal costs. Marginal benefits also go by the name of the social cost of carbon. So we could go to the literature on the social cost of carbon, heaven help any professors contributing to that literature, and that might give us a number like, say, 200, right, which is what I'm currently suggesting. Yeah, but there's another way to do it as well.
I guess looking back, the marginal abatement cost, but like the highest.
Exactly. So we could go back to week 5. We were looking at IPCC AR6. We were looking at evidence from the models run in IPCC AR6 on what the prices are in these models when they deliver a climate goal like 1.5 degrees with no or limited overshoot. Okay, that gives us a benchmark carbon price in a cost effectiveness setup, right? Where these models are not run with damages in mind, but they're run to work out what should the carbon price be if everybody were reducing emissions in line with the 1.5 degrees goal. So those are two different sources of evidence that we could bring to bear here. We could go to the literature on the social cost of carbon, or we could go to the mitigation cost models, and they will give us indications of what price level we would need all countries to be pricing their emissions at in order to be on track for our temperature goals. Just a little bit more about carbon price levels. So what World Bank helpfully also did was, first of all, they just calculated the average price. I think this is the unweighted average price across all the systems. And then they calculated the emissions weighted global price. So in other words, taking all the pricing schemes, weighting the price by the share of emissions covered, and then taking all the emissions that are not covered and pricing them at 0. Yeah? And from that calculation, you get a price of just 5, okay? which is a price-based expression of how badly we're doing on climate change. Okay? Because we would need this to be somewhere much more up to sort of between 50 and 100 at least, okay? And we're at 5. Now, one thing I would say about this is that to say that the 72% of global emissions that are not covered by carbon pricing schemes are not priced is actually an overstatement, okay? Because some of these emissions can be covered by command and control instruments, right? Or even things like fuel taxes, okay? Now, these are not explicit carbon pricing schemes, but they do implicitly price carbon. So we need to invoke the concept of an implicit carbon price if we really want to do this properly. And the World Bank is, you know, it's perfectly fine that it's doing this. No, I'm not really criticizing them, but it's not the complete answer to this question of how much are we doing, because you would want to calculate something called the implicit carbon price for all the non-price schemes that nevertheless try to control carbon emissions. And next week I'll talk to you about, you know, there are hundreds of those. Yeah.
Like this, how would we calculate oil subsidies? Negative price?
Yeah, so that would be implicitly negatively pricing carbon. So you'd probably want to put that in there too. So that's a great point. Thank you for throwing that in there. So sort of fossil fuel subsidies. So while I said that while I said this might be too pessimistic a picture because we're ignoring climate policies that don't work through explicit prices, it may in some ways be too optimistic a picture because it doesn't account for the fact that in many places we still subsidize fossil fuels, which is effectively like a negative carbon price. And IMF does a lot of good work on that, and has done for many years. Good. Okay, let's move on. This is just briefly. So carbon taxes and ETSs with auctioning generate revenues for governments. So this pair of charts shows you how much revenue these schemes raise overall. And it also shows you, I think this is very interesting, what they're spent on. Okay, so revenues are obviously a function of the carbon price. So when the price goes up, say the allowance price goes up in an ETS, revenues will go up. It also goes up when this particular metric goes up when the share of emissions covered goes up. And the method of allowance allocation obviously matters. So the more we auction allowances in ETSs, the more revenue we raise. In terms of what it's spent on, so this chart divides it into four different categories. So the largest category has always been sort of earmarking, basically, the revenues for investing in environmental and development projects or policies. Then currently about 20% is used to try to sort of essentially offset the negative impact of the carbon price on the regulated entities, right? So for example, that might be concerns about the distributional effects of carbon prices, effects on poor households and things like that, or peripheral regions, those kind of social justice concerns. So, you know, the money might be spent that way. Money might be spent in reducing other taxes. So this is this idea of the double dividend and ecological tax reform. Or the money might just be used to generally increase fiscal space. Okay. Now, we don't really have time to talk about this today, but I think a very interesting sort of question is this the right? Are these the right shares, right? I worked in the Treasury for a while. As a public finance person, I would say earmarking is a terrible idea, right? Because it's a bit like, imagine you're running your own personal budget and you're being told that every last £10 of your budget needs to be spent on specific things no matter what. You know, as a Treasury official, this is just a nightmare. You just want the money to flow into the public budget and you want to take an independent decision about what to spend it on. So basically you want to increase fiscal space. But carbon taxes and auctioned allowances are not popular. And in order to make them work politically, it can be necessary to explicitly tie their introduction to promising to spend money on good things, like green projects or helping out poor households. And not, you know, these are legitimate uses of the money. But really the story here is that to make them carbon pricing politically possible, sometimes you need to formally connect the pricing scheme with this use of proceeds. Okay, so let's move on. So let's go through a few steps in setting up an ETS. Okay, so I'm going to start with a very simple chart. This is from ICAP. It's sort of just a super simple schematic of the kind of decision stages in setting up an emissions trading system. I'm focusing here on an emissions trading system rather than the carbon tax because it does have more steps. It's a more complicated question, although some of the steps are the same for a carbon tax. I'm not going to talk about all of these steps today. I don't think we need to talk about prepare. That sounds like a good thing to do. Engage stakeholders. Yeah, I mean, yeah. We're going to talk about scope. We're going to talk about set the cap. We're going to talk about allocate allowances. And then later we'll talk about offsets. So, scope, first of all. So, as I've sort of mentioned a bit today, ETSs never cover all the emissions in the economy. They usually focus on the highest emitting sectors, most notably power and heavy industry. Their coverage of things like land use, agriculture, the waste sector is virtually zero. I'm not saying this is necessarily a good thing. Eventually, all emissions need to be covered. And if we were to achieve the impossible and do it efficiently, all emissions would have to be covered and priced at the same level. But there is a certain logic for starting with with power and industry. The idea here is that these sectors have a large share of emissions. The emitters themselves are very concentrated, right? So there are few large installations like power plants, steel mills, right? Monitoring, reporting, and verification is therefore easier, and all of this just means that the transaction or administrative costs of the scheme are lower. So that is the main set of explanations for why coverage goes like this. Okay? So that's one thing. Now, somewhat related to the scope question is quite, in what I think is always quite an interesting question, which is about supply chains. It's about where in a supply chain do you actually introduce the requirement to hold allowances? Because it's actually not obvious. So this chart, which I think does the job really nicely, so it looks at, you can see here are three different supply chains, right? The supply chain for electricity, the supply chain for transport, and the supply chain for agriculture. Okay. So at the top we've got the uppermost part of the supply chain, and at the bottom we've got the end of the supply chain. Next to each of these supply chains is the actual point that emissions are produced, which you can see is different for the three supply chains. So in the electricity supply chain, emissions are produced midstream when fossil fuels are combusted in power plants. Yeah. By contrast, in the transport sector, the point source of pollution is downstream in things like cars, trucks, planes, and so on. And in agriculture, The third example, the point source is largely upstream in farms. So the emissions footprint of what you eat is, I mean, yes, there are some transportation emissions and so on, but it's basically, a lot of it is agriculture. Okay? Now, somebody designing an ETS has to make a conscious decision about where in the supply chain to actually introduce the requirement of allowances. In the EU ETS, they are, and the EU ETS of these three sectors only covers electricity. Okay? Allowances have to be held by installations. It's the official word, an installation. And an installation is basically a plant midstream. So an individual power plant is an installation in the EU ETS. And that's the organizational unit that has to hold an allowance. Okay? Or if this were, say, the steel sector, it would be the steel plant, which we would also think about as being midstream. Okay? Upstream in the steel sector is like mining of iron ore, right? Downstream in the steel sector is like rebar going into buildings. Yeah? So basically the EU ETS allocates midstream. Is that a good idea? Well, there are different perspectives on this. The more you go upstream, basically the fewer transaction costs there are in most sectors because you are dealing with fewer and fewer agents. That's not true of agriculture because you're dealing with millions of farms, but certainly in transport and electricity, as you go upstream, you're generally reducing transaction costs. Some people argue that you get a better behavioral response the more downstream you move. Okay? That is not true in a simple economic model where people maximize profits and utility, then they will respond perfectly to prices. But if you think you're in a more behavioral world where people don't respond perfectly to prices, then you might want to go more downstream where people can actually see the effect of the carbon price on what they're paying. Because the genius of the EU ETS, the reason why it's the world's most successful climate policy ever, or one of the reasons, is that most Europeans probably don't even realize that they're paying more for everything because carbon is being priced midstream in their supply chains. But if you could do it downstream, they would be more aware of it. But of course, that may make it politically harder. So that's the third issue here. Politically, where is the easiest place to put it? The reason why it's often midstream is because downstream consumers are just going to put on yellow vests and walk roads. Imagine that happening. It's a very different political problem upstream, but the political problem upstream is very often that finance ministries already tax fossil fuel producers and importers a lot just to finance the public budget and are worried about introducing an additional cost pressure up there. Okay, so this is scope. I need to say one more thing about scope before I want to just comment on EU ETS 2. Right, so I need to move a bit more quickly now, so I'm just going to go through this a bit. So EU ETS 1 covers power, industry, and a few other sectors like aviation. It doesn't cover things like buildings, so like burning gas and boilers and furnaces. It doesn't cover transport, and it doesn't cover small industrial uses. The EU could have tried to include those in the EU ETS 1, but it has gone down a different route. It is creating a second ETS called EU ETS 2, which is going to cover them because it's dealing with supply chains that look like transport. It is actually going fairly upstream in where it's allocating the permits. So it's not requiring individual motorists or keepers to hold allowances, because that would be very administratively costly. It's actually putting the requirement to hold allowances on the retailers and distributors of the fuels. And there's a whole interesting discussion that we could have about whether it was a good idea to deal with these sectors through a separate ETS versus trying to bring them into EU ETS 1. I don't really have time to discuss that now, but it is something you might want to go away and think about. So we've done scope. Now we need to talk about the cap level. We can actually do this pretty quickly because it came up earlier. I think you were raising it. So like actually how do you set the cap? Well, in the EU and in many other jurisdictions, this question is actually not so hard. You work backwards from your international climate commitments under the Paris Agreement. These are called nationally determined contributions, or NDCs. You might have heard of that. The EU has an NDC for 2030 and makes a decision about how much it expects the EU ETS sectors to contribute to that. So its overall reduction is going to be minus 55%, of which the EU ETS is going to contribute minus 62%. Basic point here is that you would generally be guided in setting your overall cap level by, as a country, or even a subnational jurisdiction, about what climate commitments you've made more broadly. And you want your ETS to be in service of those commitments. Allocation method. Okay, so we talked in mini lecture 7.3 about the difference between auctioning and free allocation. We talked about how there are many reasons why we would want to do auctioning from an economic point of view and to an extent from a sort of distributional point of view. But we also talked about how free allocation is politically easier, at least to start with. And so you can exactly see that evolution in the EU ETS. It was basically all free allocation to start with, and over time the amount of allowances that are auctioned has increased. And nowadays free allocation is basically just used to deal with competitiveness, but even then, with the advent of the carbon border adjustment mechanism, which I'll talk about in 2 weeks' time, we no longer need free allocation to deal with competitiveness. Okay, so and you'll see this kind of evolution in lots of ETSs. You start with free allocation, it kind of purchases acquiescence from firms. They're like, all right, okay. Some firms may even make windfall profits. I talked about that in the video. But over time, you take away that free allocation and you make firms pay. I'm going to move on. Last thing I want to talk about, 2 more things I want to talk about. So one is phases, banking and borrowing. That came up earlier, so I won't spend too much time talking about it. Cap and trade schemes are often divided into phases, but if you do that, it can create barriers to firms arbitraging intertemporally, okay? And that may prevent the carbon price from following an efficient path over time. So if you were in Frank Venman's lectures, he'll probably have talked to you about how under a carbon budget you would expect the carbon price to follow the Telling rule. Did he tell you about that? If you start, so you'd expect it to be growing at the interest rate. If you then slap phases on top of this and you don't allow firms to bank permits for later periods or potentially borrow from later periods to the present, you may get in the way of the price following that efficient path. It's a little bit like saying 2 firms in the same period have different marginal costs, therefore they don't observe the equity margin, they don't satisfy the equity marginal principle, so it's a bit like that. It's a bit like saying that introducing phases gets in the way of the equity marginal principle being satisfied, but it is a little bit more complicated in the temporal dimension because it would not be efficient for the marginal abatement cost to always be equal anyway. It would follow an increasing path. That's basically just what I'm saying. So if you have phases, you would want to allow banking and or borrowing. Under certain circumstances, banking would be sufficient. And the EU ETS has learned from its mistakes there, and now there is indefinite banking, right? So we're kind of getting into the situation where firms can perfectly arbitrage between current prices and expected future prices and make decisions about what they're going to do. last thing is basically related to this issue of hybrid instruments. So a standard worry with emissions trading systems is that is price volatility, which is, can be bad from an efficiency point of view. We spoke in mini lecture 7.2 about how you could make an ETS more tax-like by introducing a price floor and a price ceiling. The EU ETS basically has that. It's got a mechanism called the Market Stability Reserve. It's complicated, but basically the idea is that if scarcity gets high enough, then more allowances are freed up to be auctioned into the system, putting a cap on the price. And if scarcity is low enough, there's a symmetrical mechanism for making fewer allowances available at auction. In that way, you can basically start to produce this stepwise supply function that I showed you in the video. So that's what that's about. Is very much, the MSR is very much a product of the 2010s, when people were really stressed out about low prices and they were trying to figure out ways to push up the price. But it doesn't just work in those situations, it can also work in situations where prices are very high. Okay, I went quite quickly through that because I wanted to make sure that I just had enough time to talk to you about carbon crediting and the voluntary carbon market. So what are we talking about here? So far I've been talking about compliance carbon markets. So firms don't participate in these markets voluntarily. The regulator comes in and says, I'm introducing a cap and trade system. It's going to cover you. This is the cap. You're required to hold allowances to cover your emissions. And if you don't, we're going to fine you. It's a classic compliance instrument. But there is another market out there where entities generate credits voluntarily and other entities purchase them, either because they have a regulatory requirement to do so, or because it's fully voluntary. Okay, so definition of a carbon crediting mechanism is a system where tradable credits are generated voluntarily. In this context, the critical issue becomes defining what emissions would have been in the absence of the emissions reducing project, right? So the example here that I put out in an earlier version of the World Bank report is a wastewater plant which currently vents methane, right? So very powerful greenhouse gas, and is considering building a facility which would capture and combust the methane to generate electricity. Okay. That would, it would then sell the electricity. It would still produce CO2, but that would reduce emissions. Therefore, in the crediting system, it can potentially sell emissions amounting to the difference between what it otherwise would have emitted, BAU, and what it's emitting after the project. So that's down here. It could potentially sell carbon credits corresponding to the amount of emissions it reduced in building this facility. Okay. Now, what makes what makes carbon credit markets slightly messy is that although it's true to say that the hallmark of a carbon credit is that it's generated voluntarily, some of the activity in the carbon credit market does occur under the auspices of governments. And that's what this chart kind of shows. So when you think about the supply of carbon credits, you're probably thinking mainly about independent crediting mechanisms like Gold Standard or Verra. These give rise to carbon offsets which are frequently purchased by consumers. So when you take a flight and you're given an option to offset, it might be a credit generated under one of these independent crediting schemes. It might even be an uncredited scheme, but that would be most people want their credits to be generated through one of these certification schemes like Gold Standard and Verra. But there are some government policies which also generate credits. How can that be? You're thinking surely government means compliance. Well, actually, there are some government systems where participation is voluntary, right? Like in the Australian carbon pricing system. So technically, it's a crediting mechanism, and also credit generation and sales that happen under the auspices of the Paris Agreement. Say, you mentioned this, so countries generating emissions reduction credits to sell to other countries, like Colombia selling to Singapore, that we would understand that as being belonging here, an international crediting mechanism, okay? And so these are the three main sources of supply of credits. The main sources of demand are, as I said, people who want to reduce their carbon footprint, firms that have made net zero pledges to reduce their carbon footprint, but also some government schemes, including compliance markets, allow the use of carbon credits towards compliance. So analytically, that's a pain. That's blurring the boundaries between the compliance market and the voluntary market, right, or the credit market, because some schemes will actually allow firms to avoid paying the tax or purchasing allowance in the ETS as long as they've got credits that they've bought from outside. Okay, that can happen. The airline industry has its own system called CORSIA, where it asks airlines to purchase carbon credits to reduce their net carbon footprint. And Singapore would be an example of a buyer of credits generated through international crediting mechanisms from a country like Colombia. So it's a bit of a pain to explain the credit market, right? It's not just the voluntary market. There are some blurred boundaries between the voluntary market and the compliance market. Mainly up here, where compliance markets sometimes allow the use of credits. And there's also a sort of a blurred boundary between the voluntary market and the concept of government schemes. Okay. Let's look at prices in the credit market. Okay. Now, so this is World Bank data as usual. I think there are basically 3 points I want to make here. The first is that the prices are pretty low. You probably know that. So you've probably taken a flight, you've been given a chance to offset. You've taken a flight to Sydney. It's a very long flight, emits a lot of CO2, and you were probably told that for $4.99 you could clean your conscience. Well, that is because you can get carbon credits on the voluntary market for extremely low prices. The second thing that you see about the voluntary market, the credit market, which is not true of compliance markets, is that there is price differentiation. So you would not see this within a single compliance market. Within a single compliance market like the EU ETS, there would be one price. It would be the equilibrium of supply and demand. In the credit market, you see different prices. Why do you see different prices? Because the products are not perfect substitutes. Right? Broadly speaking, there are three different buyers of carbon credits. There are people or organizations that want the cheapest possible. There are, secondly, organizations that want maximum environmental integrity. We'll talk about this in a minute, but they're going to go towards things like carbon removals, where they can be sure that they're actually paying for a genuinely additional emissions reduction. And they would be prepared to pay a premium for that. The third kind of buyer is somebody who wants to buy a carbon credit, but is willing to pay to provide co-benefits, say in the form of development. So an example here would be someone who buys a clean cook stove project in a least developed country. They want to reduce carbon, but they're also interested in alleviating poverty. So you see broadly three different types of buyer in this market, and the different credits that are available have perform differently on the attributes that these buyers are interested in, so you see price differentiation. The last point is, why have prices been trending downwards? Well, basically the issue here is a crisis of confidence in the credit market. And I'll motivate that by talking about a sort of cautionary tale. So the example here is EasyJet, one of Europe's largest low-cost airlines. Okay, so EasyJet announced in 2019 that they would be the world's first carbon-neutral airline by offsetting all their emissions. So they claimed that they would immediately be carbon-neutral. So, forget about net zero by 2050. Right? They were like, no, we're going to be carbon-neutral immediately. And the reason they were able to make this claim is because they purchased enough credits on the voluntary carbon market through, for example, Gold Standard and Verra, in order to cover their entire corporate carbon footprint, basically burning jet fuel. That's basically an airline's entire carbon footprint, right? So this was like this marketing coup, right? What a genius idea. We're moving into a world in which people worry about their carbon footprints, don't like to fly very much, and suddenly EasyJet realized that for a very low cost, they can get an edge on their rivals by saying, you can fly with us. It's okay, because we've offset all our emissions. So you can be guilt-free. But there was a backlash, because people were concerned that the credits they were purchasing were junk, basically, and EasyJet very quickly performed a volte-face and decided that they were not, they dropped their commitment, they dropped their offset purchases and said, we're just going to work on long-term reducing our emissions. So why did they do this? What are the underlying problems that are being referred to here? Well, they broadly fall into three categories: additionality, permanence, and leakage. You might have heard of these, right? So I've got no time, sorry. So additionality is the idea that, if going back to the introductory slide for this section, essentially, how do you know that the wastewater plant wouldn't have done this anyway? Because it's quite a good example, really, because this methane combustion facility, this is going to generate electricity, which is going to be able to sell. So maybe the wastewater plant would have made a good return on its investment even without the carbon credits. So how do we know that the emissions reductions here are real? How do we know it's not just merely inflating its business as usual? Okay? This is a particular problem with a voluntary system that relies on defining a business as usual level. Okay, so that's the additionality problem. The permanence problem is particularly associated with nature-based solution. The paradigmatic example is planting a forest to reduce emissions. So planting a forest to reduce emissions, it really would reduce emissions, but not if it does. Yeah? And the problem is there have been some high-profile examples of organizations planting forests to offset their emissions reduction activities, rock bands, for example, and then investigative journalists, those pesky people, go along later and find a dead plantation because nobody's cared for it. Okay, so that's the permanence problem, or it could be wildfires, right? It can come along and burn your forest away. And the last issue is leakage, not leakage in the industrial sense, but leakage in the sense of, say, your crediting project is avoiding deforestation. So it's like payment for ecosystem services. You're basically saying, I'm generating credits by putting a fence around my forest. How do you know that the cattle rancher who now can't destroy your bit of forest isn't just going to go to another bit of forest and cut it down instead? In which case there would be no emissions gain, right, or no net reduction in emissions. It's just the deforestation would happen somewhere else. These are all important concerns about the voluntary market, about carbon credits. They apply more to some kinds of credit than others. There are some serious attempts out there in the literature to estimate the scale of some of these problems. For example, some former colleagues of mine estimated that at least 50% of wind projects credited in India under a sort of early version of the voluntary market were not additional. They would have happened anyway, but the developers realized that they could also get carbon credits to make their investments even more profitable. So basically, that is it. I'll leave the summary to you to review later. I just want to finish, though, with one interesting conundrum. I've left you with several of these today. I appreciate that. I'm sorry, not sorry. Okay. So another thing that happened at about the time EasyJet withdrew its offsetting policy is aviation went into the EU ETS. Now, if you take a flight within Europe, or between the UK and Europe, because the UK has its own ETS, aviation is also included. Say if I fly from Paris to Rome, okay? The airline will have to acquire permits to cover the emissions associated with my flight from Paris to Rome. Therefore, I leave you with the following question. Does my flight from Paris to Rome